times e to the negative x squared from negative infinity to infinity. This is our integral. The integral from negative infinity to infinity of x times e to the negative x squared dx. Before we dive into solving this, let's visualize what this function looks like. Here's the graph of x times e to the negative x squared. Notice something interesting about this function. It's odd symmetric about the y-axis. This means that for any x value, the function value at negative x is the negative of the function value at x. This is important because when we integrate an odd function from negative infinity to infinity, the negative area on the left will exactly cancel out the positive area on the right. Let's solve this integral using u substitution. Let u equal negative x squared. Then du equals negative 2x dx. Solving for x dx, we get negative 1/2 du. Now we can rewrite our integral. The integral becomes negative 1/2 times the integral from negative infinity to infinity of e to the u du. Next, we can evaluate this integral. This becomes negative 1/2 times e to the u evaluated from negative infinity to infinity. Substituting back u equals negative x squared, we get negative 1/2 times e to the negative x squared evaluated from negative infinity to infinity. When we evaluate this, as x approaches infinity, e to the negative x squared approaches 0. And as x approaches negative infinity, e to the negative x squared also approaches 0. So we get negative 1/2 times 0 minus 0, which equals 0. This result makes perfect sense because of what we observed earlier about the function being odd symmetric. The integral of an odd function over a symmetric interval is always 0, as the negative and positive areas cancel each other out exactly. Therefore, we can conclude that the integral from negative infinity to infinity of x times e to the negative x squared dx equals 0.